Hello everybody, this is David here again with another Verilog video using the Basys 3 FPGA. This time I'm going to create a state machine that is a candy machine and operate it using the Basys 3. So what will be involved on the Basys 3 is going to be, well, these three buttons. The top one is going to represent inputting a quarter, the middle one a dime, the bottom one a nickel. This is a 25-cent candy machine. This one over here will be the reset. We'll have these 16 LEDs in play here for like an attention grabber, and then everything else will be outputted on the 7-segment display. So let me take you to the code. Alright, here we are in Xilinx Vivado. Over here under design sources, here's our top module. Inside we have 4 button debouncers for the 4 buttons. We have the state machine, an LED driver to drive the 16 LEDs, a 2 Hz generator that will provide the synchronizing signal for the LED driver, a 10 Hz generator that we're going to put into the state machine, and we're going to also have a BCD kind of converter. It's not a byte converter, but it's going to work for this particular purpose. And then a 7-segment display control. And then of course here's our constraints file down here, and I'll go through each one of these files. Here's the top. We have an input of the 100 megahertz clock, the buttons for reset, 25 cents, 10 cents, 5 cents, the 7 segments of the 7-segment display, the 4 anodes of the 7-segment display, and the 16 LEDs are input-output interface for the whole system. Let me take you over to the block diagram. Okay, here's the block diagram for the candy machine. This big block in the middle represents what we're going to code in Verilog in our circuitry. We're going to have 4 buttons. I didn't put the reset, but it's there. But we're going to have the button for 25 cents, 10 cents, 5 cents. Each of those will go through a button debouncer, and then onto that output will go onto the state machine. The 100 megahertz clock is going to get converted into a 10 hertz signal through this module and then fed into the state machine. This 100 megahertz will also be converted into 2 hertz to drive the LEDs. We'll send the 100 megahertz over to the 7-segment display control. It also goes into each of the button debouncers, but just to keep the clutter of the lines down, I didn't draw it there. Once we're in the FSM, we'll have signals. We'll send a signal out that will be the amount of change that will be converted into a BCD and fed to 7-segment. We'll also have some signals from the FSM, mainly the state, going into control the segments based on the state. And then 7-segment control controls the 7-segment display LEDs, and the LED driver controls the 16 LEDs. Okay, back in Vivado, I'll take you through each of the modules. We'll start with the button debouncer, simple one that I've used before. We got an input clock, a button in, and a button out signal. We have 3 temporary registers, always at the clock. Button in will become A will go into B will go into C. Not button in will become A will become button in, and it'll ripple through, and we will debounce the signal, and we will tie in the button out wire to the last register that gets assigned. Now the 2 hertz generator, it's a lot like the 1 hertz generator. I mean, it's a clock divider, so whatever signal you want out, right here is the number that you have to manipulate. So before, for a 1 hertz signal, I would use 49, basically 50 mega, which is half of this. Well, I want a 2 hertz signal, so I want basically 100 megahertz divided by 4, which gives me 25 megahertz, but we're counting from 0 So it's 25 megahertz minus 1 is where we want the register to reset, and then also toggle our clock 2 hertz that's connected to the clock out register that gets toggled right here. And then same type of deal with the 10 hertz generator. We're going to divide this by 10, and we end up with 10 mega, which is 0 to 9 meg, 999,999. And we do the same thing. We just toggle a signal. Okay, onto the LED driver. This is essentially a multiplexer, basically. So we're going to have the 2 hertz signal come in, and we have our output LEDs, which are the 16 LEDs on the Basys 3. And then I set up a register of 16 bits with 0, 1, 0, 1, 0, 1, and then the next one is 1, 0, 1, 0 all the way through. So, and then I assign the LED out based on what the value of the clock is. The clock is going to go from 0 to 1, 0 to 1. So when the clock is 1, we're going to have the register of scheme 1 being the LED value. So it'll be this top one here. And then when the clock goes low, we're going to end up having the value on here. So in effect, it's going to create a back and forth blinking effect of the LEDs. Okay, here's our state machine. We have the clock coming in. This is actually changed to 10 hertz now. It really wasn't working right with the clock speed, so I changed this to 10. That's why I got the 10 hertz now. But that's the clock coming in. Got the reset button, the button for 25 cents, button for 10, button for 5. We're going to output the state to the 7-segment control, and we're going to also output the amount of change for the 7-segment control, because we're going to display the amount of change that gets returned after anything more than 25 cents. Okay, a couple registers here that we're going to use for state transitions, and I'll show you those in a little bit. We have 7 states, so we need a 3-bit state reg, and here are all the parameters for the states. And then at this time, I'll take you over to the state transition diagram. Okay, here it is. We'll start off with idle right here. I didn't put the R for reset, but this is our initial state, or our reset state. And each state basically represents the amount of money that has been input into the machine. So if you put in a nickel, you go to 5 cents. You put in a dime, you go to 10 cents. You put in a quarter, you go right to 25 cents. And then all the connections between states, like if you put in a nickel and then a dime, you can go to 15 cents. Or if you put a nickel and then a quarter, you go right to the 25 cents, and then you'll end up having 5 cents for your change return. So these are all the ways that you can get to the different states based on these 3 inputs, which nickel, dime, and quarter are worth 5 cents, 10 cents, and 25 cents, of course, right? And then the outputs are going to be the candy and the change. And these will both be represented on the 7-segment display as an output, and you'll see that not too much later from now. I'll take you back to some more modules. Okay, back in Vivado, back in our state machine.v Verilog program. So that's what all the states for. You just saw the diagram. Now we come down into the changing the state logic. So always at the clock, pause clock, or reset. If it's reset, we're going to set the state register to idle. That's our reset state. Now else, we're going to go into a case in case of the state reg. If it's in idle, we're going to set the amount of change to 0. And then if the 25 comes in, we're going to go to the state 25-cent state. Else, if a dime comes in, we're going to go to the 10-cent state. And if a nickel comes in, we're going to go to the 5-cent state. So you can see how this is working. It's going to work the same way for each state. So if you're at 5 cents and you put in a quarter, you're going to go to the quarter state, but then you're also going to have a change of 5. So from 5 cents, if you put in a dime, you're going to go to the 15 cents. If you put in another nickel, you're going to go to the 10. So each one of these is set up the same exact way based on the value coming in of a nickel, a dime, or a quarter, and you will go to the state that represents the amount of money that's in the machine. And now when we get down to the 25-cent state, this is where, okay, you get a candy, but we're not going to have a candy output from this, but the 7-segment control is going to know that it's in this state, and then it's going to view a message on there for that you got the candy, and then it's going to remain in this state for 3 seconds. That's what this counter reg is down here. That's what it was at the top, and here's how they're controlled down here. There's one for this state, and then there's one for this state. The reason why there's 2 different registers is because I did have different times for them, but I made them the same. But here's their control down here, so they only count up to 29, and they use the 10 hertz signal that comes in here. So 30 ticks divided by 10 gives you 3 hertz, you know. So that's how these counters are activated when you get to their respective state, and then once they get to that number, we'll transition out of the state to another state. And then this is just assigning the output of the state to the state register that goes over to the 7-segment control. Now, the reason why I need a BCD converter is for the change, because you can have a change value of 0, 5, 10, you can't have 15, you can have 20. Well, I guess you could, yeah, you could have 15. If you put in a nickel and a dime and then put in a quarter, you get 15. But anyway, it's covered in the code, and you'll see. But this is where I bring in the state machine is outputting a 5-bit value that's changed, and that value is coming in here. And then I'm creating 2 registers for 10s and 1s, and then I'll take that value and divide it by 10, because the most this value is ever going to be is 20 as far as the value of change. You can put in 2 dimes and then a quarter, and then the change will be 20. So, you know, we're only going to have 2 at the most for a 10's value of change for 20. And then when we do modulus on that value, then we get the remainder, whatever the 1's place is, and that'll be a 4-bit BCD value, and that's either going to be, that's only going to be 0 or 5. And then that's outputted, and it's right here, the 10s and 1s register through to these outputs, and then this is connected to the 7-segment display control. We got change high and change low. We also bring in the state, a clock, and a reset. This clock is 100 megahertz. We have the outputs registers for the segments and the anodes. Down here I just create a bunch of parameters, so when I go through and assign the values for the segments, it doesn't look like this. I can basically symbolically do it with these parameter names here. Here's a couple of registers I create to switch through the anodes, because as you know, if you're using multiple 7-segment displays, you need to cycle through each display at a fast rate, so it looks as though they're all on at the same time, but they're actually being cycled through. That's what all this code is for right here. There's a timer right here, so basically the 100 megahertz is split up, so it changes like 1,000 times a second between anodes. And then down here is where I set up the logic for the segments. And so we have always at the clock in the case of the state coming in. So if we're in the idle state, in the case of the anode, if this anode is on with a 0, it'll be null. And then this anode will be a B, this anode will be a U, and this anode will be a Y as it cycles through. So in the idle state, it's just going to have the word BUY for buy. And then for every state until you get to the 25-cent state, it's going to just be the amount of change you put in. So if you hit button 5, it's going to show the number 5 in this anode right here in this digit. And then 10 cents, it's going to show you how much change you put in the machine. Then when you get to the 25-cent state, you know you got a candy because it's going to say enjoy. the letters NJOY are going to come up on the 7-segment display. And then 3 seconds later, after that counter in the state machine switches to the change state, we're going to see the letter CH and then the amount of change on the next 2 digits based on the value of change high, which comes from this BCD converter, and change low. So we're either going to have a 1 or a 2 or a 0 or nothing, null for this digit, or we're going to have a 0 or a 5 or nothing for this digit. And that's basically it for each of the modules. The top module just ties them all together. Got a bunch of wires here that can basically make the connections between all of the instantiated modules. There's no other new logic or anything inside the top module. Here's the XDC file, which is Xilinx design constraints for the Basys 3 board. We got to bring in the clock from the master XDC, all 16 LEDs, the 7 segments, the 4 anodes, and then 4 of the 5 buttons down here, and rename them to match all of the signals that are in the input-output interface for our top module. I went ahead and ran the synthesis, ran the implementation, generated the bit stream. As you can see up here in the upper right, it says write bit stream complete. So at this time, I'm going to go ahead and plug in my board, turn it on. I'm going to open the hardware manager and open the target and program it, and then I will show you the candy machine working on the Basys 3. Alrighty, here's the Basys 3 candy machine. You can see how it says buy. We're in that idle state, and the lights are switching back and forth. That's like the attention grabber, like, hey, candy machine, come buy something, right? So I'm going to go ahead and hit reset just to make sure it's back where I want it to be. And so now I can buy some candy. So now if I just go ahead and put in a quarter, which is the top button, it says enjoy. I just got my candy. And then it's going to tell me how much change I get. Change of 0. Right? Obviously, right? Now it's back to where I can buy another piece of candy. Let me try and put in 3 dimes. Oh, I know I got 10. I got 20. Oh, I don't know why I went back to 15. There's a little glitch there, but now I got my candy. Let's see how much change it's going to give me. 5, which is right, because you put in 3 dimes, you get 30 cents, you get your candy, and then you get 5 cents back. Let me try some nickels here. There's 5, 10. There's another nickel. Oh, I got 20. Oh, I'm out of nickels. Hey, let me borrow a quarter. Boom. Okay, I get my candy. Alright, let me get my 20 cents back. Boom, there it is. Change 20. So there you can see a working candy machine, state machine on the Basys 3. Thanks for watching.